First, I'm looking at the syllabus. We are on week number 16. This week, you have to study sections 9.4 and 9.5, which I will go over them today. And your quiz, okay, is going to be tomorrow. So it would be available tonight before I go to bed. And you have the whole day, Thursday, tomorrow, to finish the quiz number 7. Is due 11:59 p.m. tomorrow. And the same thing with your homework 7, part 1, which is 84, 85, 91, 94. 4 sections. Homework, the same 4 sections, quiz number 7. And then next week, by the way, if you go to modules week 16, you will see the review for final exam. And the next week, under module for week number 17, you're going to see the solution to the final review. Next week, again, you're going to have a Zoom class meeting. I'm going to cover 12.1 and answer your question on the final exam review, if you have any. And week 18 is your final exam, which is on Wednesday and Thursday. So you will have access to final exam Wednesday morning at 12 a.m. and is due, your final exam is due Thursday, 11:59 p.m., December 14. And your homework 7 part 2 is due, again, December, ignore due 12/13. But if you go to modules, you will see, or the assignment, you will see the due date. So your homework 7 part 2 is due December 14, 11:59 p.m. The same thing, homework 7 part 1 is due tomorrow, 11:30, 30th of November, 11:59 p.m. Okay, any question about quiz 7, final exam, homework 7 part 1 and homework 7 part 2? Okay. I don't know if I went through section 9.4 last week quickly or not. I think I did.
You did it very fast at the end.
Yes. Because I just wanted you to have exposure to that lesson, because your quiz your quiz for tomorrow covers this section. So testing the difference between two proportions. What is remember, for chapter 9 and chapter 12, we are only doing p-value method for chapter 9 and 12. But chapter 8, you are responsible for traditional method and p-value method. Chapter 8, 2 method, traditional method and p-value method. The textbook doesn't mention traditional method when it's giving you homework, but when it gets to the p-value method, it says use p-value method. But chapter 9, even if the book doesn't mention traditional method, all the problem of chapter 9 and 12 are p-value method. So no matter what method we are following, you have to know the test formula, a test value formula. This is test value for difference between two proportion, P1 hat minus P2 hat minus the difference between P1 and P2 times the square root of P bar times Q bar times 1 over N1 plus 1 over N2. You do not have to memorize this formula or use it, because we are for chapter 9 and 12, we are using our calculator to find the p-value and test value. But anyway, I'm just going to mention the formula. P bar under the radical sign, the first factor is x1 plus x2 divided by n1 plus n2. Q bar is 1 minus p bar. And same as before, P1 hat is X1 over N1, P2 hat is X2 over N2. P1 minus P1 hat minus P2 hat is observed difference. P1 minus P2 is expected difference and is always equal to 0. You will see P1 minus P2 in null sentence, HO sentence. Again, you do not have to memorize this formula or use it. You're going to get the value for Z from your calculator. Using TI 84 or 83 for hypothesis testing for proportion. As a chapter 7 or chapter 8 that we discussed, chapter 7 was finding confidence interval, chapter 8 was hypothesis testing for proportion. We use Z-test for proportion. We use Z-test for proportion. There is only one test for proportion, Z-test. And when you are using Z distribution for proportion, and the test that we're going to use from the calculator, we only have statistics option. We don't have data option. So you go to click the stat key. On the stat, you pick the last option test. Under test, you pick to prop Z test for hypothesis testing. Prop is for proportion. You're going to type the appropriate value that we have given you. Then you move your cursor to H1 because you have to tell the calculator if you have a true tail test, left tail test, right tail test, and you press enter. And then you move your cursor to calculate and press enter. Let's look at example. According to the US Department of Education, 51.9% of women and 46.7% of men receive financial aid in undergraduate school. A random sample of undergraduate students revealed the following result. I will show you in a minute. At alpha equal to 0.01, is there sufficient evidence to conclude that the difference in the proportion has changed? Use p-value method. So let me go. I don't think I have enough. Yeah, these are the data that I have given you. This is the statistics, one for women and one for men. X1, 200 for women, X2, 180 for men, N1, sample size 250 for women, 300 for men. So we have given you sample size for each group, and out of those 250, 200 of women said they use financial aid. 180 out of 300 men said they use financial aid. These are the statistics we have given. Okay. Again, the problem on the corner. Let me see if I can move this. You can see it. Yep. So what is the, I always ask you, as you've seen in the previous quiz and this quiz that you will see tomorrow and final exam or PowerPoints, I ask you, you have to give me the name of your parameter. Parameter is proportion. Parameter is proportion P. If you know the parameter, then you can go and look at correct formulas, the handout that I have given you. What is the claim? Claim says that the difference in proportion, the proportions are different from each other. The proportions are different from each other. So proportion, population proportion of first group, P1, is not equal to proportion of the second group, P2 men. And then I ask you, write on the quiz and exam, I ask you to give me the data that I have given you. Just copy this data on the quiz and exam. First of all, since we have proportion, we are using z-test. Okay, z-test. Okay, what type of test do we choose from the calculator? Since we have two groups of population and parameter is proportion, we go to our calculator, we choose 2-prop z-test. And we only have a statistics. 2-prop z-test. Statistics version. There is no data version for proportion. Okay, so these are all the information. Even on the quiz, I ask you, give me the name of the test. And you have to circle the 2-prop z-test. Or if I haven't given you the option, you write 2-prop z-test. Okay, now are 5 steps. You must write the step number next to each step and put the step number inside the box. The first step of hypothesis testing is writing your null hypothesis, alternative hypothesis. Tell me which one of the HO or H1 is the claim and give me the name of the tail test. Please do not give me one tail when you have right and left. You have to specifically tell me right tail or left tail. Do not tell me one tail. Some of you did that on the quiz. So since claim is P1 not equal to P2, this claim goes with H1, alternative hypothesis. So this is a step number. I write H1 first. H1, P1 not equal to P2. Right away, I write this was the claim because you need all of these for other steps. And this is a two-tail test. Then I would write, after I'm done with all the information that I need to write for H1, I write my null hypothesis. HO is P1 equal to P2. Okay. Then for the second step and the third step, I'm going to use my calculator. Okay. I'm going to use my calculator. So let me, for a second, you have the information. If you have the PowerPoint open, you have the information in front of you, okay? So let me go to the stop sharing, have my calculator up. Okay. These bars are a little bit. Okay, I click the stat key. Okay, stat key. On the top row, I will pick test. I need the test comes at the beginning. All the tests are at the beginning. We have to choose 2-prop z-test. Item number 6, 2-prop z-test. X1 is 200. N1, 250. X2 was 180. N2 was 300. Then we had the we put the information of H1 on the line that is blinking. You had P1 not equal to P2. So this is first option. It is already on the first option, so I don't have to go to the right. So I go down, I ignore the green, highlight, calculate, press enter. First of all, I put my float on 2, but I'm going to change that. Click float mode, put my float on 4. Quit. So one more time, stat test, the 2-prop z test. All the numbers are here already. Here the first line tells you that what is your claim, P1 not equal to P2. Z, that's your test value, 5.5 0.0539, p-value 4.3362 e to the negative 7. You have to write, if your p or your z has e attached to it, you have to copy that, then move your decimal point according to what your e is. Okay, do not ignore the e, because if you ignore the e, you're going to have a wrong result. Okay, let me stop sharing my calculator. So from the calculator, z is 5.0539. P-value was 4.3362 e to the negative 7. So what does that mean? E to the negative 7, move your decimal point 7 places to the left. One of the places is for 4, then I should move it 6 more after 4. So that's why I have 6 0 before 4. 1, 2, 3, 4, 5, 6. So this is my p-value. Copy the whole thing, okay? Point, decimal point 6043362. Okay. And then step 4 is I have to decide to reject or not reject null. To do that, I compare my p-value with alpha. I write p-value on the left, alpha on the right. My p-value is very, very small, approximately 0. My alpha is 0.01. Then I ask myself, which one is larger? Alpha is larger. P-value on the left, alpha on the right. I put the values. I put the mouth of my inequality toward the larger number, alpha. Okay. Then I read the sentence from left to right. So p-value is less than alpha. When p-value is less than alpha, it means that p-value is in the alpha region. P-value is less than alpha. So means p-value is in the alpha region. Alpha region is a rejection region. So we're going to reject the null hypothesis. Now we are down to a step number 5, which we have to write our summary. To write the summary depends on 2 information. What is our claim, and if we rejected or not rejected null. So claim was H1 because P1 was not equal to P2. And from a step 4, this is a step 1, that's a step 4, we rejected null. So according to the outcomes of hypothesis testing, this is outcome of your hypothesis testing. And for the summary, I want one of the 4 boxes, one of them. Exactly the same sentences. Okay, so claim was H1, so I'm on the second row, H1, and I rejected the null. So I have to write as a summary, there is enough evidence to support the claim. Exactly the way you see it, underline is, underline support, same sentence. Here is my summary, same sentence. Any question from anybody? Okay. Okay, I did not look at any example, but other examples are similar. Now, in chapter 9, after we talk about hypothesis testing for, let's say, mean, we also talk about confidence interval for mean, which we did that in 7.1. Now, in 7.4, we did hypothesis testing for proportion, now confidence interval for proportion when you have 2 populations. Here is the formula. Don't be scared. You are not using this because you're going to find confidence interval, the interval, the number on the left and the number on the right of P minus P1 minus P2 from the calculator, okay? So read the problem from the middle. P1 minus P2 less than P1 hat minus P2 hat times marginal error greater than P1 minus P2 is greater than P1 hat minus P2 hat minus marginal error. Okay, how do you get a confidence interval for difference between two proportions using your calculator? Again, we are using z-test. We only have statistics. You go to stat, you pick test this time, you pick two prop for proportion z, because we are using z-test, but we are using z distribution, but we are finding interval, int, two prop z int for interval. You're going to enter your x1, n1, x2, n2, and you're going to give the calculator your confidence level, like 95%, 99%, or 90%, whatever we are given. Sometimes, instead of giving you x1 and x2 in your statistics that I give you P1 hat and P2 hat. But when you go to your calculator, you need to know what is your x1 and x2. How do you find x1 and x2 when I give you P1 hat, N1, P2 hat, and N2? We know that P1 hat is x1 over N1. If I put imaginary 1 under P1 hat and cross multiply, I get x1 is equal to P1 hat times N1. Okay. And x1, like n1, are either number of people or number of items. You have to round to whole number, round up to whole number. You cannot have x1 as, you cannot have a decimal number for your x1. Why? Because x1 is the either number of people or number of items. Now you follow the same procedure. We know that P2 hat is x2 over n2. By cross multiplying, you get x2 is P2 hat minus n2. Again, you have to round up your answer to whole number.
If you forget to round it, your calculator will let you know, because it will tell you there's an error there.
Yes,
it will only take whole number values for x. So
then you're going to highlight calculate, press enter. Okay. Example, in the nursing home study, the researchers found that 12 out of 34 small nursing homes had a resident vaccination of less than 80%, while 17 out of 24 large nursing homes had a resident vaccination rate of less than 80%. Find the 95% confidence interval for difference of proportion. So we want to find 95% confidence interval for two proportions. When they say difference of proportion, is telling you that you have two groups, okay? And your parameter is proportion. So what are our two groups? Small nursing home and large nursing home. Since the problem started talking about small nursing home, so I'm going to call small nursing home group 1. Okay, parameter is proportion. And we are using z-test. Again, we only have a statistics. We're going to use two prop z int. Okay. Now we're going to discuss what are our groups. Small nursing home is going to be my group 1. A large nursing home going to be my group 2. So N1 for small nursing home is 34. Sample size was 34, N1. And 12 is your X1. So you're okay. I have given you X1. For large nursing home, N2 was 24. x2 was 17. So in this case, I have given you n1 and x1, what you need. But if I have given you n1 and p1 hat, n2 and p2 hat, you have to use the formula x1 would be p1 hat times n1 and round your answer up to whole number. Okay, so let's go to my calculator. Let me stop sharing. Bring my calculator up. So I have, can you see my calculator, Shana?
We can see it, yes.
Okay, so I click the stat key. I'm on the top row. I'm going to go to test. Now, as you said, when you go to your test menu, at the beginning, you have all the tests. 1 through 6 is the test. And then after 7 and on, it starts with interval. You want 2 prop z int. Okay, this is z interval, no. T interval, no. 2 sample z int, no. 2 sample z int is when your parameter is the mean. 9.1, section 9.1. For if you want to find confidence interval for mean when you have 2 population, you pick 9. 2 sample t int, no. This is for 9.2 and 9.3, which I did not cover. 1 prop z int, no. We have 2 population. 2 prop z int, b. We need b. Okay. What is my x1? 12. What is my n1? 34. What is my x2? 17. What is n2? 24. My confidence level, you had to find 95% confidence interval. Change your 95% confidence level to decimal, which the generic C level is always 0.95. But don't forget, if your confidence level is 90%, change a generic C level to 0.90 or 0.99. I don't have to do any change. Calculate, highlight, calculate, press enter. This is your confidence interval. So let me copy this number in my PowerPoint. So here it is. Either you put your interval inside parentheses or you write P1 minus P2. On the left side of your inequality, you put the first number from left to right, then second number. Now, we know that proportion is the percentage. And percentage cannot be negative because a percentage is a number between 0 and 1. But we cannot have negative percentage. So what's wrong here? My groups are wrong. So what do? You're going to call group 1 large nursing home and call group 2 small nursing home. Since proportion percent cannot be negative, we must change our group. So I did that. I call large nursing group 1. So N1 is 24 and X1 is 17. Small nursing group, small nursing home group 2, N2 34, X2 12. Then I repeat the same process. I went to stat, test, 2 prop z int, and I just changed my numbers. And I end up with correct numbers. So basically what happened before that, I didn't change, I had the small nursing group as group 1. On the left side of my inequality, I had negative 0.5980. On the right side, I have negative 0.1128. But when I change my group, the numbers, the position of the numbers switched, and the negative changed to positive. And I like to always change my answer for proportion to percent, only proportion, not mean, not variance. Now, if, for instance, if, any question about the example 2?
One thing I wanted to point out, and this happens a lot, if you get to a place on your calculator and it doesn't look like it's asking for the right information. If, for example, you had chosen 2SAMP Z int instead of 2prop Z int, your screen would look different and it would ask for information you don't have. If your screen has information you don't have, you're probably on the wrong screen, trying to do the wrong interval or the wrong hypothesis test. So don't force it to work if it doesn't work. Look at your inputs, okay? It happens more often than you think.
Okay, thank you, Shona. Now, if, let's say, can you see my screen?
We can, but we're seeing your slide right now.
Yeah, this slide, yeah, this slide. A slide is fine. Suppose if you have the following. You, suppose originally you pick a large nursing home as group 1, small nursing group as a group 2, and you end up with the following interval, okay? The number on the left is negative, the number on the right is positive, okay? Do not switch groups anymore, because if you switch the group, these numbers gonna switch location and the sign will be this. So basically you're going to get the following. If you switch the group, sorry, if one number is negative, one number is positive, you're going to, if you switch the group, you're going to get so if one of the numbers on the, if the number on the left is negative, the number on the right side is positive, if then you say, oh, I have to switch the group because proportion cannot be negative. If you switch the group, this happens. Again, on the left, you end up with a negative number, on the right with positive number. So what do? Do not switch group anymore. All you do, you change the negative decimal to 0. So you say, well, okay, just change the negative number on the left to 0, which means that your P1 minus P2 is less than 59.80% and larger than 0%. Okay. Any question?
So just
okay, please mute yourself if you hear your telephone ringing. Go ahead, Shana.
So just to clarify, we only switch groups if both sides are negative.
Yes, you only switch groups when both sides are negative. If one side, if the left number is negative, the right number is positive, just change the left number to 0.
To 0. Okay.
Okay. That's 9.4. Any question before I start the 9.5? Any question on homework?
Somebody is asking for 9.1 number 4, but I can do it after class if you'd like.
Okay, thank you, Shauna. If I have time, what time is it? It's 11:41. We are here till 1 o'clock. So let me finish 9.5, then I will answer that homework problem. Okay.
Thank you
Or
so much.
Shauna can explain. Okay, testing the difference between two variances or two standard deviation, two variances and standard deviation, 9.5. When you have two population, you want to find hypothesis testing for two variances and two standard deviation, or finding confidence interval. Now, when you have two population, you are not going to use for variance and standard deviation chi-square test. You're going to use F-test. 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 What are the characteristics of F distribution? F distribution is a positively skewed distribution, like chi-square distribution. And so F values are positive, like chi-square distribution. They are positive. Because the variances are always positive or 0. Again, as I mentioned, F distribution is a positively skewed distribution. The mean the mean value for F is approximately is equal to 1. With the F distribution, we have 2 degrees of freedom. Okay, one for denominator, one for numerator. Okay, the F distribution is a family of curves, and we have 2 degrees of freedom, one for numerator, one for denominator. What is the test value for F distribution? F is S1 square over S2 square. Okay. Now, this bullet is very, very, very important. The larger of the two variances, because I'm going to give you either 2 sets of raw data or 2 sets of statistics. Like I'm going to give you, let's say, variance. If I give you a statistics, I may give you variances of group 1, variances of group 2, sample size, and so forth, mean or whatever of each group. So you have to look at the group. You pick the group that has larger variance as group 1. You call group with larger variance as group 1. So the larger of 2 variances is placed in the numerator, regardless of the subscript. So what I do is I look at which group has larger variance, and I call it group 1. Even if the book called it group 2. I switched groups. I said, well, I don't like the way my book or the professor Nikdel called this group. I want the group with the larger variance to be group 1 and just change the subscript. So the larger of two variances is placed in the numerator regardless of the subscript. Or always make group with the larger variance as group 1. Why is that? Because no, sorry, ignore what I said. Okay.
Because we need the F to be greater than 1.
Yes, yes.
And that's a mathematical condition of how the F is calculated. But if you happen to get those wrong, your F will be smaller than 1 and it violates the
And
assumptions.
the calculator will give you an error message. Okay. So even if you forget to put larger variance in the numerator and put the wrong one, the calculator will give you an error message and you have to remember, oh, I got an error message, so larger variance has to go in the numerator. And then again, after you choose your correct group, then you need 2 degrees of freedom, one for the denominator, one for numerator. Okay. And numerator degree of freedom is n minus 1. Degree of freedom for denominator is n2 minus 1. Remember, n1 is the sample size for which the larger variance was obtained. Again, the 3 bullets basically saying pick group 1 as a group with a larger variance. Okay. The same hypothesis testing for p-value method, same here. Okay, what are the steps? What type of test we're going to pick here? Using the TI 84 and 83 for hypothesis test for difference between 2 variances. What are the steps? We are using, when we have 2 population and we want to do hypothesis testing for variance and standard deviation, we use F distribution. What do we do for statistics? You're going to go to a stat. You're going to go to test. 2 sample F test. So far we had 2 sample Z test, 2 prop Z test, now 2 sample F test. If I have given you a statistics, you go and highlight the statistics. If I have given you data, you highlight data in front of input. Type in appropriate value that we have given you. Move the cursor to put your correct H1 sign. This is for what type of test you have, right tail, left tail, two tail. Highlight, calculate, press enter. What do you do for the data? Enter the data values in list 1 and list 2. Copy down the standard deviation S sub x. So after you enter your data in list 1 and list 2, you have to copy whatever information the calculator gives you. And to do that, you go to calculate, you go to a stat, go to calculate, pick one word stat. Under, they ask you what is your list, put list 1, press enter. Under when a new window comes, copy S sub x for standard deviation. Do the same thing for list 2. Okay, after you switch S sub x from each one word stat, then decide which group is group 1. So if S sub x1 is smaller than S sub x2, switch your group. Then you go to a stat pick test to sample F test. Move the cursor to data and press enter. This is when you have data. Then type appropriate value that you have. Move the cursor, choose appropriate sign for H1, your tail test, press enter. Highlight calculate, press enter. So these steps are same as before. Like for to sample F test, to prop, to sample Z test, to prop Z test. The same thing here. Do I have any? No. Okay. Example 1, a researcher wishes to see whether the variance of the heart rate in beat per minute of a smoker is different from the variance of heart rate of people who do not smoke. 2 samples are selected and the data are given below. Use alpha equal to 0.01, test the claim using p-value method. Here is smoker information, non-smoker information. Well, I right away look at the variance. S1 to the power of 2 means the variance for first group is 36. That's larger than 10. So they gave me a correct group. So I'm not going to switch group. Okay. And I want to find the test the claim. First of all, my parameter is variance. And what is the claim? Sigma 1 square, which is sigma square is variance. So I have to put subscript. Sigma square sub 1, sigma square sub 2. They are not equal to each other. They're different from each other. Parameter is variance sigma square. Claim sigma 2 sub 1 not equal sigma 2 sub 2. Now, since I have 2 population, my parameter is variance, I'm using F test. And they have given me a statistics. My group are correct. Okay, let me write my, okay, smoker group has a larger variance, so it's going to be group 1, G1 for group 1. Good. I have subscript 1, so it is correct group. To sample F test, I have to use to sample F test. So what is my first step? My claim goes to H1 because I have not equal sign. So H1, this is the sentence that goes in front of H1 colon. That's my claim, and I have a two-tail test. So I write my H1 first, then I write my null. H sub 0 is sigma square sub 2 equals sigma square sub, sigma square sub 1 equal sigma square sub 2. Okay. To find the test value and p-value, I use my calculator. So let me stop sharing. Okay. I go to a stat, test, to sample F test. I don't see the F test in the first window. To sample T int chi-square test. To sample F test. Under input, I put the statistics. It is already on the statistics. So I go to my S sub X1. Okay. The calculator is asking for standard deviation, not variance. So what I do, since I want the standard deviation and they gave me variance, I have to take the square root of variance. So I get square root of 36. Please, please focus. Do not put S square sub 1 for S sub 1. Okay, you have to take the square root. What is N1? 26. What is S2? Square root of 10. What is N2? 18. Well, for H1, I had sigma square 1 not equal sigma square 2. So it is, the generic location is always first one. So I don't change it. This is my test value, 3F. Test value, the formula starts with the F. F is 3.6. That's my p-value. Okay. I have copied these numbers into my PowerPoint. Okay, when entering S sub x1, that's you have to take the square root. Test value F was 3.6. P-value was P.0084. Now to decide to reject or not reject null, I have to compare my p-value with alpha. Step 4. P-value, I write it on the left, alpha on the right, put the values. The outcome of my inequality is toward the larger number, 0.05. Then I read my sentence from left to right. P-value is less than alpha. So it means that 0.0084 is in the alpha region, rejection region. So I'm going to reject null. Then my claim was H1, and I rejected null. According to the hypothesis testing, claim was H1, I rejected null. There is enough evidence to support the claim that sigma square 1 is not equal to sigma square sub 2. Any question? Okay. Second example, an instructor hypothesizes that the standard deviation of the final exam grades in her statistic class is larger for the male group, for the male students than it is for the female student. We have given you statistics for female group and male group. We want to test the claim when alpha is 0.01, we are using p-value method. We want to see if standard deviation of male group is larger than the standard deviation of the female group. First of all, our parameter is a standard deviation, sigma. Our parameter is a standard deviation, sigma. Now, I look at my two groups. I see that variance of the first group, 2.3, variance of the second group is 4.1. I have to switch the group. I need 4.1 to be group 1, 2.3 group 2. So right away, I switch my group. First of all, parameter, standard deviation, sigma. Male group has a larger variance, so it's going to be group 1. And I'm going to use 2 sample F test. I switch my groups. Male is going to be group 1. Then S sub 1 square is 4.2. N1, 16. So this I will switch the subscript of male group to 1 subscript. Then female is group 2, change subscript to 2. So S square sub 2, 2.3, and to 18. What is my claim? The claim was that standard deviation of male group larger than the standard deviation of female group. Now, male group is group 1. So again, standard deviation sigma of group 1 larger than standard deviation of group 2. That's my claim. Okay. Sorry. So my claim goes with H1 again, because sigma 1 larger than sigma 2 goes with H1. That's my group, and I have a right tail test. Then null sigma 1 less than or equal sigma 2. Sigma 1 less than or equal sigma 2. I always want to see if null has less than or equal or greater than or equal. I want to see that. Then the other equivalent is sigma 1 equals sigma 2. But I want to see that first. Okay. To find step 2, I'm going to go and use my calculator. Remember, I switched the group. So let me stop sharing. So two sample F test, stat test. I don't see two sample F test. Instead of going down, I'm going to go up, which takes me to second page, and two sample F test. Where is two sample F test? Oh, here it is, E, two sample F test. I have a statistics, okay. What is S sub 1? Remember, I switch groups. So male group is group 1. So I said square root of, I'm going to clear this, square root of 4.2. What is sample size for male group? 16. What is standard deviation for female group? Square root of 2.3. What is the sample size for female group? 18. What is the sign for H1? Greater than sign. Sigma 1 larger than sigma 2. Calculate, highlight, calculate, press enter. That's test value, that's p value. 1.8261.1165. Okay, I'm going to put these numbers in the PowerPoint. Okay, now I have step 4. I have to decide to reject or not reject null. I compare my p-value with alpha. P-value, write it on the left, alpha on the right, and the mouth of inequality, open it toward the larger number, your p-value. Read your sentence from left to right. P-value is larger than alpha. It means that your p-value is outside the alpha region. Outside alpha region means in the non-rejection region. So we do not reject null. When p-value is larger than alpha, not reject null. Okay. For the summary, Our claim was H1 and we did not reject null. So according to our hypothesis testing outcome, there is not enough evidence to support the claim. Question? Claim was H1. We did not reject null. So there is not enough evidence to support the claim. Your step 5, it has to be one of the 4 boxes. Do not forget to underline is not, support, or reject, whatever you have. In this section, there is no formula for confidence interval. So we are done with chapter 9, hypothesis testing, and in some of the section, confidence interval for 2 population. For mean, we had z-test. We are not doing a t-test for mean in chapter 9, 2 population. Then we had hypothesis testing and confidence interval for proportion, z-test. And then we only had hypothesis testing for 2 variances and standard deviation, f-test, not chi-square test, f-test. Okay. Any question? So we are done with chapter 9. We only have one more section, and that's chapter 12, ANOVA, analysis of variances.
And that went up. There was a help video that went up for that this morning.
Okay.
So if you need it, just reminding you, Professor, somebody had asked for 9.1 number 4 earlier.
Okay, in a minute. So can I have like 5 minutes break?
Sure, we have time.
Yeah, let's have 5 minutes break. I need break. Then I'm gonna go over that problem. So you said okay, the U.S. Census Bureau reports that the average commuting time for citizens of both Baltimore, Maryland, and Miami, Florida is approximately 29 minutes. To see if their commuting time appear to be any different in the winter, random sample of 40 drivers were surveyed in each city, and the average commuting time for month of January was calculated for both cities. The result of shown here, Miami, sample size 40, mean for the sample 28.5 minutes, population standard deviation, sigma sub 1, 7.2, this is X1 bar. Then for Baltimore, again, sample size N2 was 40, X2 bar, 35.2 minutes, sigma 2 was 9.1 minutes. So here, since we are talking about average, parameter is mean, okay? Now, let's read the rest of the problem. The results are shown, here it is, we discussed that, at alpha equal to 0.05 or at the 0.05 level of significance. Level of significance is the same as alpha. So sometimes I say at alpha equal to 0.05 or at level at the 0.05 level of significance. Can it be concluded commuting times are different in winter? So claim is that mu1 not equal mu2. Mean of population for the first group is not equal to mean of population for the second group. Okay. Now, since we have 2 population and sigma is given for both groups, sample size are larger than 40, we're going to use z-test. Okay. So we're going to two sample z-test. I have not given you raw data. I have given you a statistics. So we're going to go to a statistics, two sample z-test statistics. Okay. Before I do that, my claim mu1 not equal to mu2 goes with H1. So H1 is the claim, and I have a two-tailed test. And null hypothesis, HO, mu1 equal mu2. Okay, so let me stop sharing and bring my calculator. No, let me clear this window. You go to stat, click the stat key, test, two sample z-test, two sample z-test number 3. I gave you a statistics for input. Okay. What is sigma 1? 7.2. Sorry, I have to move this a little bit to the right and left to see the numbers. Okay, sigma 1, 7.2, variance of Miami group. Sigma 2 variance of, standard deviation of Miami. Sigma 2 standard deviation of Baltimore, 9.1. What is mean of the sample for Miami? 28.5. What is sample size for Miami? 40. What is mean for Baltimore? 35.2. Sample size 40 again. What is H1? What type of tail test do we have? Mu1 not equal mu2. We're going to choose the first option. Go down. We don't want color. Highlight, calculate, press enter. So that's your Z, negative 3.6518, P 2.6052, E to the negative 4. Do not ignore E to the negative 4. E to the negative 4 means you have to move the decimal point 4 places to the left. I'm going to put this on my, I put these numbers on the slide. So Z was negative 3.6518. P was 2.6052 e to the negative 4. And I move, let me rewrite what I had from the calculator. Originally, I had 2.6052
6052 e to the negative 4.
52 e to the negative 4.
Mm-hmm.
So what I did was I moved my decimal point 4 places to the left. One place is for the 2, then I end up with 3 zeros, 3 more zeros. So I get 1, 2, 3. Okay. Now I to decide to reject or not reject null, I'm going to compare my p-value with alpha, which was a 0.05. The p-value is smaller than alpha. The amount of his inequality is toward alpha because alpha is larger. So it means that p-value is smaller than alpha. So p-value is following the alpha region, which is a rejection region. So I'm going to reject my null. Now, our summary. Our claim was H1 and we rejected H0. And according to outcomes of hypothesis testing, claim was H1 and I rejected null. So there is enough evidence to support the claim.
I think someone is a little confused about how to enter the data in the first place. Somebody asked where 7.2 came from.
7.2?
It's given as part.
7.2, here it is. This was given to you.
Oh, okay, got you.
Because when I went
So
to
on
the
the calculator-
calculator, you could not see this window, but I located my calculator. Somehow I could see this window also.
Okay, okay. I didn't read that part, the population standard deviation. I see it now.
Okay.
So in the calculator, I would not add this part, right? The population standard deviation.
Oh, you have to. They ask you.
and-
Let me show you.
Yeah, can you show that again? Because, and keep in mind that your data may not be in the same order that your calculator asks for also. So
Yeah.
I meant like on L1, L2.
No, no,
put it
no,
in
no.
there as well.
No.
Okay, that's what I meant. So I don't put it in there.
This is a statistics. If I give you a statistics, you do not work with L1 and L2. If I give you raw data for each group, raw data, bunch of numbers for Miami, bunch of numbers for Baltimore, then you have to put the numbers for Miami in list 1, then numbers for Baltimore in list 2. Then after you are done entering data in list 1 and list 2, go to a stat, calculate one word stat. You pick these these 3 numbers from one word stat for from the calculator. By the way, if I give you raw data, you are not going to pick sigma from calculator. You're going to pick S sub X. So that number 7.2 and 9.1 would be different.
Okay, got you. Yeah. I was
Okay.
reading all this wrong then. I was thinking these were just datas, but thank you.
Yeah.
it's a good question. It's not the
Yes.
first time it's happened to somebody. These
Yeah.
are summary statistics, and how you know that is it says sample size, remember that's N, okay? Sample mean, remember that's X bar. Population standard deviation, that's sigma. Now we have 2 groups, so we have 2 sets of numbers, but this is basically 2 sets of sample statistics. This is not raw data. Okay.
Raw
Good
data,
question.
you're going to get a bunch of numbers. Like, for instance, you're going to get 40 raw data for Miami, 40 raw data for Baltimore. Then you enter those 40 number in list 1, list 2. Then when you go to one word stat, you find X1, you get X bar. Then you get not 7.2, you have to copy S sub X.
Right. Do you have an example of what raw data would, just to show that? Not to necessarily do the
For
problem,
2
but
groups,
is there, I think we did one
example.
for means. Yeah, we did one for the
Let me
means.
stop sharing and go to my
We did one
Our-
for river length. I remember there was that problem about river length that everybody asks every year.
I
But
don't know what number is that, but
yeah,
That's number 3.
number 3.
but I think I did it for the video as well. I tried
Yeah,
to
I
show
think
you
I
both.
watched it. Yeah.
Number
on there.
3, 9.1? No. Let me quickly, I'm just checking to see which of the problems has raw data. The one that I asked.
Yeah, I don't know that we have raw data for
Homework?
this that I remember. I know we have it in 8, but I don't know that.
I know that we have it in the lesson. Okay, let me bring the lesson 9.1. I think I had raw data in lesson 9.1. Yes. Let me bring, here it is. Yeah. Here is raw data. Raw data is bunch of number for each group. Are you seeing my slide?
Yes, we can see that.
Okay, so what I did was I enter, first of all, parameter is the mean. They are saying that the mean of Birmingham is larger than the mean of Chicago. So I enter my raw data for Birmingham in list 1 and information of Chicago in list 2. Okay, mean of Birmingham larger than mean of Chicago and so forth. I think I don't have the numbers, but
No, you didn't provide the summary
okay, let
statistics.
me just do that. Shauna, can you read this number? I need somebody to read these numbers for me. You have
let me-
access to?
I have to pull down the slide right now, and
Okay, let me just
not-
do the Birmingham. Let me just look at them. Hold on a second.
Let me see if I can
Don't worry about it.
finagle, because I think they're about to start drilling again.
Okay, don't worry about it. So I'm just going to do one group. So I go edit, enter the raw data for Birmingham under list 1. So I get 78, 82. I have the list in front of me, so that's why I'm copying the raw data for Birmingham to my calculator.
68,
Yes, 67.
67, 68, 75,
Mhm.
73, 75, 64, 68, 62,
Hold on a second. And then
73, 77, 78, 79, 74, 72, 73, 78, 68, 73, 79, 82, 71, 66.
Okay.
You want Chicago as well?
Yes, let's enter Chicago. Do you have the list?
I can see it on the slide that you're sharing, yes.
Okay, so let me move my PowerPoint a little bit to the right. Okay, I think now you can see. So go ahead.
70,
Okay,
74, 73, 60, 77, 71,
wait, hold
72,
on. So 70, 74, 73, 60, 77.
71, 72, 71,
I can read it. 74, 76, 71,
mhm,
80, 65, 70, 83, 67, 76, 75, 62, 65, 66, 65, 77, 66,
and
64.
Mhm.
Okay. Now, remember, in this example, I have given you sigma 1 and sigma 2, okay? Sigma 2 was 5.7, sigma 1 was 5.39. So I don't want to copy standard deviation anymore because they have given me population standard deviation. So I quit from this window. I go to stat, calculate. I pick one word stat, list one, highlight the calculate. I copy X bar on a piece of paper and N. Okay. So X1 bar 72.92, N1 25. Okay. Copy it on your paper. Okay. Now quit the window again. Go to
You're not
stat.
displaying the calculator screen. We just see your slide.
Oh,
We
how
just,
about right now?
no.
Am I on the
Just-
slide?
Just your slide. Yeah, we can see your slide slid over, but you're not sharing both windows at the same time.
Okay. So let me share my calculator. Okay.
There
So,
you go. Now we can see. You're on the edit
okay.
screen.
So let me quit again. Stat, edit. I already entered raw data in my list. So I go to calculate. One word stat, I put list one. Can you copy these two numbers? Do you have a
Sure,
pencil?
I can do that. 72.92.
For X bar sub 1 and N1 25.
72.92
N1 25.
and N1 25. Got it.
Okay, let's quit this window and let's go to stat. Calculate one word stat. This one list 2.
Mm-hmm. What do we got? 70.8.
70.8. That's X bar sub 2, N2 25.
Mm-hmm.
Okay.
70.8 and then 225. Got it.
Okay. Now, when you go to the question, you have to do 2 sample F tests, correct?
Why are we doing means here?
Yeah,
We're doing
we are doing
means.
mean.
So it's 2 sample
Sorry, 2 sample Z test. Sorry, 2 sample Z test.
tests.
Okay.
Yeah,
And can you
remember,
copy, Shauna, 2 numbers for me?
I did that. Uh-huh.
Sigma 1 is 5.31.
Sigma 1 is
5.39.
5.31. Got it.
39.
And sigma 2?
5.70.
5.7, 5.39, you said?
Yes, 9.
And 5.70.
Yes.
Yes, ma'am. I have that.
Okay. So let me, are you on my calculator window?
Yes, we are.
Okay.
You
So
are
you
on
go
your
to
home
stat,
screen right now.
tests, 2 sample Z test. We had raw data, so you highlight the data, press enter. Then what is sigma 1?
5.39.
What was sigma 2?
5.70.
Okay, now you didn't have to go look at what I see here. It says list 1 L1, so yes. List 2 L2, yes. So you don't have to go to one word stat and copy N1 and X bar. Because that takes this list 1 L1, list 2 L2, it takes care of what you enter in your lists. So you don't need copy X bar and N from one word stat for each list. That would take care of it, okay?
When you do it for stats, you do.
Yes.
That's
yes,
where they come from.
yes. For stats, they ask you, you have to enter them. But when you say data, and you put the L1 for list 1, L2 for list 2. Calculator is calculating it itself. Then I highlight, I go to mu1 and I put larger than mu2. Highlight, calculate, press enter, and this is my test value, that's my p-value. And it gave me x1 bar, x2 bar, standard deviation n1 and n2. I don't need them to copy that, but if you want to copy them, that's fine. That's your test value, that's your p-value. Okay.
Thank you, Professor. I don't see any more. Does anybody else have any more questions?
So if you don't have any question, go back and study a little bit more for your quiz. And don't forget about final exam review on Canvas and its solution next week. So next week, we have Zoom class meeting. I'm going to cover only 12.1 and answer your question on the review if you have any. If you don't have any question on the review, then the meeting is going to be a short meeting, just one section.
Somebody asked when you're going to post the final exam.
What do you mean, post the final? It's going to be final week. Wednesday, you will have access to your final exam on Wednesday and Thursday of your final.
Yeah, so the final's not going to be in person either. I think that was somebody's question.
Yeah, it's not going to be in person, and it's going to be online. Hold on a second. Let me bring
for the person who asked, let's give Professor Nikdel a minute to bring up the syllabus for you.
Here is the syllabus. Next week, I'm going to cover 12.1 ANOVA, analysis of
variance,
analysis of variance. Final exam, December 13 and 14, Wednesday, 12 a.m. You have all day Wednesday and all day Thursday, 48 hours. The exam is not, it doesn't take anybody 48 hours to do my final exam. If you sit on your desk and do the final, maximum it takes 3 hours, maximum of 3 hours. You know, so if somebody has a disability, I'm not going to give them, you already have 48 hours. I'm not going to double 48 hours. Because as I said, if you sit in the classroom and take this final exam, it only takes you a maximum of 3 hours.
Yeah.
So even if I want to double it for students with disability, I'm not saying that I have students with disability in this classroom, but if I had to double it for students with disability, it takes them 6 hours. And 48 hours is enough.
That's the maximum that I've seen somebody take is around the 5 hour mark. And that's if you look everything up. And if you go back to all the sections and do all that. But yeah, I expect it to take between 3 and 4 hours to do.
Yeah, if you know the material. But if you're in the classroom, I'm not going to give you more than 3 hours to do this final exam. The whole thing. Okay. So 48 hours is enough.
So don't panic. It's doable. It's a little bit
doable.
long,
I mean, you have seen the questions. You have not seen the question from chapter, what do you call it? Chapter
12.
You haven't seen any question from chapter 12, but you have seen question from chapter 8 and 9 in quizzes 7 and 6 and 7.
And there's plenty of help on the videos. Somebody's asking for you to repeat when it's available. Wednesday. Did you say Wednesday at midnight?
Wednesday at 12 a.m. Wednesday 12 a.m. means when I want to sleep on Tuesday, suppose I sleep, I want to go to bed 11:40 on Tuesday night. So by 11:49, you have access to my exam. Understand?
So
Wednesday, 12 a.m. means you have the whole
Wednesday
day
early in the
Wednesday.
morning until Thursday night. Okay, got
Yeah.
it.
Wednesday the whole day, Thursday the whole day.
And just because people always ask this, yes, there will be tutoring those days. It will be adjusted for you. No, we haven't made the schedule yet. So
Okay.
we will make the schedule after Shauna gets the schedule for for my other training in my other class. So you will know in plenty of time. You'll know by next class meeting more than likely.
Yeah. And also, there is no extension on the final exam. And please, please be neat when you are doing your final exam. Follow the procedure. Don't give me information that I'm not asking you. I have given you a sample. Do you see my PowerPoint? Okay, how my PowerPoint goes? Your work should be similar to the PowerPoint, or let me go to modules.
And it should look like the exam review looks.
Yeah, exam review. Yes, your work should be similar to the exam review. And I think we put an example in
Yes.
section 8.2, I think.
Yeah, there's examples. If you need to know where they are, you can ask me.
Yeah, if you go
Okay.
to 8.2 lesson, is it 8.2, maybe 8.1?
I think it's, are you talking
On the
about
homework
the
part.
hypothesis testing example or
Yeah, it
the,
is in the homework page.
yeah, it's on the homework page for hypothesis testing for that. So it's there.
What is this? No, this is the hypothesis testing rules and point system on the homework quizzes and final exam. Please follow this.
If you have questions about anything that you're doing as far as your work, if it's right, if you're presenting it properly, I'm happy to answer that.
Okay, here is example of how each problem on your homework should look like. You do not need this flow chart, but if you like to put it there, that's fine, but there is no need for that.
But you can ask the questions. The questions should be there, but the flow chart need not be. If
you don't have to put this outcome for hypothesis testing, but if you like to put it there, that's fine. So this is how your exam and final, your quiz, exam, and homework should look. Step number, underlining, graphs, if you have to do traditional method for chapter 8, so forth.
So if you have questions about the format of your work, you can also ask me that as well.
Yeah, you can talk to Shauna.
We're more than happy to help you with that. Okay, but don't wait till 10:30 at night on. Don't, because I'll do what I did last time and send you guys a message when I log off, so you'll know. Okay, but it's available for you. All the videos have it as well. So those of you who have been participating, you know how the format looks. So don't.
And one more time,
yourselves.
one more thing, your final exam is 200 points. Remember, 200 points.
Okay.
And your quiz, the last quiz is tomorrow. Homework 7 part 1 due tomorrow night. Your quiz, it will be available 12 a.m. or maybe earlier tonight. So you have all day tomorrow to do your quiz 7. Finish your homework 7 part 1. Your homework 7 part 2 is due the day of the final exam.
Okay. Any other questions? You can email us and we'll answer that. Bring your questions for next week when we do the review and when we talk about ANOVA. As I said, the ANOVA went up and there's a homework problem as an example. So
yes,
we started with the homework for 12 for those of you who would like to start that. Don't feel obligated to start that, but if you want to, you can. Okay.
Okay. If you don't have any question, that's all for today.
Thank you, everyone.
Thank
Take
you.
care.
Bye. Bye, Shana.
Bye.
I